talk about exponential growth and decay. So identify the type of formula given, be ready to justify your answer. So just a moment ago I said I am giving you 4 formulas, right? And then I said, but really they're really only 2. Why? Why would I say that? Take a look at those. Jessica? 1 is positive and 1 is negative. So if we're talking about exponential growth and decay, would the decay be on the right or on the left?
Why did you get old?
Because you said on the right. Why would it be on the right?
No, you were like,
because you weren't owning your answer, I think. Okay, so the one on the left is decay, and the one on the right is growth. And everybody can see that we're taking one and adding. What do you think R stands for? Okay, what do you think T stands for? And A? Amount or initial amount, right? And K? Constant. Yes, it is. Okay, these 2 right here are formulas we use when we're talking about bacteria growth or carbon decay, things that scientists use because of the constant rate. What's the matter? Okay, I don't want to get, I think the hardest part about this is students trying to figure out which one you would use. But the homework, we're going to go through each. I don't want you guys to get scared and bogged down by that. Before we leave today, or before you leave today, I want to go through the homework problems and make sure you understand which one to use, which one you would use and why. Okay? So we'll go through that. What I really want you is just to be doing the calculations, not trying to figure out which equation to use. I told you guys. Okay? Off my game. All right, so pencils down. Let me just set this one up for you. So a store is offering a clearance sale on a certain type of digital camera. The original price for the camera, okay, so I'm going to explore the problem. They're talking about the original price is $198. The price decreases. We're talking about a decrease at 10% each week until all the cameras are sold. How many weeks will it take for the price of the cameras to drop below half the original price? Okay, so it's asking me how many weeks, and it's going to be how many weeks until half the price? Okay, so I've kind of explored the problem, pulled out the information that I need. Let's choose a formula. Okay, so do you think this would be a type of problem that we would use, that scientists would use, and we'd be talking about the constant rate? No. So it's either between this one or this one. We're talking about decrease, so we're going to use this one. Okay? Everybody good so far? All right, so let's figure out how we can substitute some of these values in here. So what could I substitute? The amount, okay, what's the amount? 198 times 1 minus 10%. Tell me what 10% is. 0.10. Good. All right, do we know T? They asked us how many weeks, so we don't know t. Do I have a value for y? Don't. Do I? Tamia? It'd be half of 198. How much is half of 198? So let's back up on this. So you've got $198, right? And you've got a rate that it's going to be decreasing, right? Decreasing by 10% for so many weeks, and the end result is half the price. Does that make sense why it's 99 now? Yeah? Okay. All right, so how could we solve this? Log to both sides? Let's simplify first. So I've got 99 equals 198. 1 minus 10% is 0.9 to t. What do I do before I take the log of both sides? I could divide. Good. So I could divide by 198. I said originally that I wasn't going to do this, but I've just decided I am. What is 99 divided by 198? 1/2, right? Now I have 0.5 equals 0.9 to the t. Now we're ready to take the log of both sides, correct? So I've got log 0.5 equals log 0.9 to t. Then I would use what? Power property. I'm going to write all the steps out for you. Got it? So you've got everything. And then just divide by log 0.9. These go away, and I'm left with t equals, I get 6.57. After you solve, you should probably go back and make sure we're answering the question. All right, I got t equals 6.57. What were we trying to find again? How many weeks? Can you have 6.57 weeks? No, so how many weeks would it take for that camera to be half off? 7 weeks. So it would be about 7 weeks. Okay? Okay, go ahead and write that down. Anybody have questions on how we set that up? Not too terribly difficult, right? All right, let's try another one. A specimen, what do you think is going to happen? Science one. A specimen that originally contained 150 milligrams of carbon-14 now contains 130 milligrams. How old is the fossil? Okay, so in a previous example, it said that carbon-14 decays at a rate of 0.00012. So whenever you have a problem that's got carbon-14, your K is 0.00012. Okay, so let's pull out and explore the problem. Specimens that originally contained 150, so original. What do we call the original? What variable do we use? A. So A would be 150. And now it contains 130. So now it's 130. What happens? That's a decrease. How old is the fossil? How old is T? That's what we're looking for. All right? So which one of these do you think I'm going to use? Very last one. Okay. So we know what A is. It's 150 e to the negative, I know what k is, 0.00012. I'm looking for t. What else do I have? What's y? So after this occurs, right, after this rate has an effect on 150, my end result will be 130. So what do I do with that? The natural log of both sides. But before I do the natural log of both sides, I want to divide by 150. Good. I should be changing my colors on these. Let's use purple. So I'm going to divide by 150 and divide by 150. And I'm going to keep this in this form because I want this to be as exact as possible. So I'm going to take the natural log of both sides, correct? So it's going to be ln of 13 over 15 equals ln e negative 0.00012 t. Okay, this becomes 1, correct? And over 15 equals negative 0.00012 t. Now what? Divide. Don't want to divide by the t part. Those cancel, and if I put this in a calculator, I get t is about 1192.5. Go back. What were we looking for? How old is it? So in years, it would be 1193 or 1192. You would round. It's not a full year. Yeah, but we're talking about decay, right? I would agree. True, I would agree with you. The book says 1193, but just because the book says it doesn't mean it. That's what? True, I agree. Let's go with 1192. Unless somebody has another way of reasoning through that. Okay, you guys ready to do one on your own?
Yeah.
Okay, let me give you a second to copy that down for those of you that haven't already. Okay, why don't you guys try this one on your own? All right, and if I had your clickers out, I would have you put it in the clicker, but I don't want to take the time to do it right now. I'll be honest. Okay, go ahead. Work together if you'd like. Okay, 5, 4, 3, 2, 1. Here's your answer.
I got it.
You're applying a formula and then you're reasoning through the problem, right? Not yet. One more, and then we can do homework. That's a good sign. Try it. You just want to know. You tell me. Okay. Try this one. You guys do this one on your own. Pause. Okay, so the first one it says can be modeled by this formula, and the second one can be modeled by this formula, where T is the number of hours. According to these models, how many hours would it take for the amount of B1 to exceed the amount of B2? No, not just start plugging stuff in. What did they just ask us for? First of all, what are we looking for? Time, how long, right? How many hours before what? Before this one is bigger than that one. How can I write that in math? This one is bigger than this one. Okay. That's fancy. Now what? Okay. So if I take the natural log of both sides, can I just do that? Can you guys allow me that? So I'll do it in a different color. Okay, then what would I do with it? Think.
It would be 0.1532 T times 1200. It's greater than it.
Okay.
But I just own it times the 3000.
But think about that for a second.
Why?
Okay. Think about if you were to use the power property and put this in front of there, which you could, then where would you go?
Then those things cancel out. And then you divide.
How do they cancel out, though?
Ln
The natural log of E is 1, but this isn't the natural log of E. This is the natural log of 1200 times E.
So it's 1200. It's 1200, isn't it?
What property could we use? This is how I did it. They have the same properties, right? Now this becomes 1, right? No? You have to split them up because, right? Got it? Right? Because multiplication is the product property, right? Is addition with log. Okay. So now I have ln 1200 plus 0.1532t. Everybody okay with that? ln 3000 plus 0.0466t. Now what? Just move stuff around? Yeah? Okay, so what do you want to move around? Let's highlight what we want on the left side.
You want all the T's on one side and the LN.
Okay, so let's leave. You want the LNs on?
You want the T's on the left side, that way it's positive.
Think about it. What, okay, about the positive part, right?
How can you have negative hours?
Then sign's going to change, right? Okay, so, because it's fun. So we want the T's to go on the left, right? Because of why, Sam? Okay. So I want to keep these positive because when I take this on this side, it's going to become negative, right? When I move it. When I move this, I have to subtract to move it, right? Okay. Does everybody get that? God, I'm just a fantastic teacher today, right?
Yes.
Okay. 1532t minus, everybody okay with that? 0.0466t. And what would go on this side? ln 3000 minus ln 1200. Can you? Can I subtract that? There's lots of different ways to look at this. You could put it in a calculator this way. How else could I change it? Isn't that the quotient property? Yeah, you could say ln 3000 over 1200 if you want to, right? You could use that property, or you could just subtract it in your calculator and hope that you use the right amount of parentheses. Right? That's what it boils down to. Okay, because now, what do we do on this side? How do I solve for t? What? Well, that would be this side. What would this side be? GCS. So we've got t, take out t, and I'm left with 0.1532 minus 0.0466. And I'm just going to, because I just want to show off, this is...
let's not show off.
This is 3,000 over 1,200, right? Which is zeros cancel, so now it's just 30 over 12, or 15 over 6. I'm just saying. You didn't have to do that, though, correct? Now what? Divide both sides. What is 0.1532 minus 0.466? 0.1066? So all of this divided by lots of different ways to write it, though, correct? How much time do we have? Not much. I got 8.59. What'd you guys get? Okay, what were we looking at? How many hours will it take the amount to exceed? So how many hours would that take? Or 8, it says in here 8.6. Well, no. That would be rounding up. It would take 8.6 hours. Because it says more than, right?
Yeah,
it has to be greater than 8.59, if you think about it. Make sense? I don't know. Okay. So I'm going to let you guys write that down, and then we're going to look at the homework problem, okay? And then jot some notes down about the homework problem, okay?